Hey everybody, Bill Sky, the FORTRAN guy, another FORTRAN video. This time we're going to continue our discussion of subroutines and functions, but instead of just creating them, we're going to show you how to create them and put them in an external object library, which you can then share with your other FORTRAN programs. You can even distribute it out on the internet, do whatever you want with those functions, and no source code, just the object file, and all you have to do is link them. So let's just jump right into it. Okay, now I'm going to use the projects that we use, or the last project, the subroutine project that we used in the last video. The functions work the same as subroutines in this context. You don't have to worry about differences. I think we're just going to see subroutines in this, but it doesn't matter because they link the same way. So what I'm going to do is I'm going to take my subroutines project and I'm just going to go ahead and copy it. And then I'm just going to rename it. I'm going to call this External Intel Subroutines. And again, you can call it X if you want. It doesn't matter. Okay. And so we're just going to take our subroutines that we had in our main program, put them in an external file, and then just go ahead and link them and take them out of our old main and then link them. It's pretty cool. So the way I'm going to do this is I'm just going to copy my main and I'm going to rename it. So I'm just going to call this ffuncs, FORTRAN funcs, and then I'm going to edit it. Now what I'm going to do here is I'm going to get rid of the main. I'm going to get rid of all of the calls to the main, and I'm just going to leave the contains and all of the subroutines that are in there. Now I'm going to go down to the bottom, and because we're no longer in the main program, I'm just going to go ahead and delete that. And then there's one other thing that we're going to do in this case. I'm going to actually create a thing called, a module. Now what modules are is they're kind of like namespaces in C++, if you're familiar with that, and they're a way for you to organize your code. So I'm going to just call this ffuncs. Now, what would I really want to call this? Well, I would want to put maybe all of my mathematical calculations. Let's say I'm a scientist, an astronomer, or a cosmologist. I would want to put all my gravitational functions in one module, maybe all of my speed functions in another, all of my galaxy stuff, whatever. It allows you to organize your functions, and that's how you do. So I'm just gonna call this ffuncs, and then down here I'm going to say in module. All right. So now I have just created my ffuncs.f90. Now I'm going to go ahead and open up my main. And from there, I want to get rid of everything in contains. And I want to leave my end program there. So everything in contains is now gone. Now I'm going to go ahead and build this, just so you can see what we get here. Oh, it's not open API, it's one API. And let's clean it and let's make it. So what we get here is we get a whole bunch of errors on the link because we didn't actually build the ffuncs file yet. And the link for the main doesn't know where those functions are when we call them, like this call multiply by. So what we have to do now is we have to change the make file. And what I'm going to do is I'm just going to copy, and I'm going to call this ffuncs.o. Make sure I put the right source file there. And this is the compile step, the -c. So that means it's going to compile ffuncs. Main is now going to be dependent upon ffuncs. And in the link, we have to put ffuncs.o. And down here now, because we have more than one O file, I'm going to change the clean from main.o to asterisk.o. All right, let's go ahead and make this. And we still have an error. We still have this thing about it doesn't know where those functions are located. And that's because inside of our main, we have to say that we're going to use the ffuncs module. So what I'm going to do is right before the implicit none, I'm going to say use ffuncs, which comes from the ffuncs.f90 module. Now there's another way we can do this, and I'm going to show you that soon, but this is how you do it using modules. I'm going to make, and voila. And I'm going to run it. And, and all of our functions work exactly the same. So our main is no longer there. All the functions are no longer in our main. They're all in a separate file now called ffuncs.o. And if I take a look at this, you can see ffuncs.o right here. So what if I wanted to let somebody use my functions? What I would do is I would send them the ffuncs.o file, which is an object file, and I would let them know that I compiled it in Intel FORTRAN. If you did it in FFortran or GFortran, you might want to let them know that as well. But that's what you send, and then you simply tell them in their codes, you're going to have a little user's guide, programmer's guide. You simply tell them in your code, in your documentation, you have to put that use : ffuncs to be able to access that file or those functions. That's how easy it is. Now, there's another way of doing this, and another way of doing it is by not using modules. What I'm going to do is I'm going to say external print hello ext for external. Now that function doesn't exist yet, or that subroutine doesn't exist yet, but I'm going to go ahead and put it in the call or in the main, and I'm going to make it. And we don't get any errors simply because, and actually let's make clean and let's make. So we don't get any kind of errors because we haven't actually tried to call that function. We haven't actually tried to do it. So I'm going to go over here, I'm going to go to the bottom of the code here, and I'm going to call that subroutine. And again, it's not a function, it's a subroutine in this case, but functions work exactly the same. I'm going to try to call that subroutine that I said was external, and we get an error. It doesn't know where print hello ext is located. So I'm going to create yet another file. So I'm going to create my second external file. I'm just going to press this, and I'm going to go over here, and let me see what I want to do here. So I'm going to create a function. Whoops. Where's that new one? There it is right there. I'm going to create a non-recursive impure subroutine called print hello ext. Now I'm defining the function or the subroutine that I called in my main that wasn't yet defined. Hello from external print hello ext. I'm going to return, and then I'm going to say m subroutine print hello ext. And that's it. Now I'm going to save it. And on this one, I think I'm going to call it ffuncs external because I used external stuff. And let's put that in the same folder as our other files. Okay. Now let's go ahead and build it. We still have a problem. It doesn't know about it because we haven't changed the make file. So, okay, so let's do the same thing for ffuncs. I'm going to do the same thing with ffuncs e. I'm just adding. And then main now also depends upon ffuncs e.o. It's going to link ffuncs e.o. And I believe that might be it. Okay, let's see what we have here. Oh, I typed subroutine wrong in my ffuncs e. There we go. And I'm going to clean it first. Oh my goodness, it worked. So let's go ahead and run it. Well, I don't know if it's worked yet. It compiled and linked. And let's go to the top. Yep. Hello from external print hello ext. So to summarize real quickly of these two different ways of creating functions or subroutines in external files, the first way I showed you was using modules in FORTRAN. It's like a namespace in C++. If you don't know what that is, go ahead and take a quick look, but it's just a way to categorize your functions in a single category, in a single container. And in this case, we just called them ffuncs. And like I said, you might want to create different ones based on the actual operation of the functions. So that's using modules. And when you do that, you have to enclose all of your functions or all of your subroutines inside of that module. And actually down here, end module, probably wouldn't be a bad idea to say ffuncs, because you might want to put multiple modules in the same source code. Let's make sure this works, and it works just fine. Okay, so it probably wouldn't be a bad idea to do that either. So that's the first way that we did it. The second way we did it was we used the external clause, and the external clause told the compiler, don't look for the print hello ext inside of my main. It's going to be linked in later. And if I go and there, if you notice there's no module, there's no nothing in there. It just has the actual function, and then it's compiled and then linked. And if we look at our makefile, we now see that both of our functions source files are being compiled only with the -c. They're compiled. And then in the overall main linkage statement in the makefile, we're linking both of those object files that we actually created in the compile. So that's how you can really make your code more portable, where then you can send the object files to people, or you can actually use those object files in your own program like we just did. Okay, so that is external subroutines and functions in FORTRAN. Kind of cool. Next video is going to be calling C functions from FORTRAN. That'll be a lot of fun. So how do I call C functions in an external object file in C from a FORTRAN program? And then after that, we're going to call FORTRAN functions from C. See you then.